Okay, hey guys. So what we decided to do was the one with Calorimetry, something that I cannot pronounce for the life of me. But at the same time, it's something that's basically easy if you just think about it very slowly and in pieces. So let's say that this sphero is an imaginable metal, has its own specific sense of specific heat. Let's say that it starts to warm up to the point of it being in 100 degrees Celsius inside this calorimeter. And we take the sphero from its calorimeter and put it into a thing of water. And the temperature of the sphero raises from 20 degrees Celsius to 42 degrees Celsius. And the sphero, being an imaginary metal, has 700 grams in itself. And the water around it is 2,000 grams. Now, how would we figure this out? Okay, so as I was saying with my group here, if this sphero is an imaginary metal, which is a 700 grams, which imagine that, and place it to a calorimeter which has 2,000 grams of water, whose temperature rose to 200 degrees, from 20 degrees Celsius up to 42 degrees Celsius, how do we figure that out? Well, you'd have to understand that Q equals the mass of the object being questioned times its specific heat by the delta of T, which is the temperature final minus the temperature initial. So, when it comes to this, we have to start off with the water first. So the Q of the water would equal 2,000 grams times the C of the water, which is 4.184, times the change in temperature, which is 22 degrees. So, if you times that all together, you get 184,096 joules, which this is how much heat the water has absorbed. If you go back to our packets, this is basically one of those questions that she said that the grammar is kind of often, but this is how you actually would find that first part. But you to find how much the metal lost, all you have to take is this Q and turn it negative, and that is how much the metal itself lost. Now to find the C of our imaginary metal. Now, we decided to say that it was boiled at 100 degrees Celsius. So to find that, you have to find the Q of the metal equals 700 times its unknown value of C by the change in temperature from final and initial. So if the final temperature is 42 degrees, you'd have to subtract the initial degrees of the metal itself, as our sphero is turning off, by 100 degrees, because that's the initial. So you would subtract 42 by 100 and get 58. Now keep that negative, because if you remember from earlier, Q is negative from this initial value from finding out how much the water absorbed. So if you times 700 and negative 58, you get 40,600 C times C. So divide each side by 40,600, and then you would get a C value of 4.53. Now, as I said before, this is a make-believe metal, so there's no real name for it, so you wouldn't have to worry about it having a specific name. But if it wasn't imaginary, this is where you'd figure out which metal is what.